Today's video will give a few examples of how to determine the level of convenience of a class. Hello, I'm James Helfrich. One of the most important metrics for encapsulation is convenience, namely how well a class serves an application it is built into. This video will evaluate several classes for convenience and show how you can evaluate level of convenience in your classes as well. Convenience is the degree in which properties are presented to the client in a format which facilitates use in an application. And there are 5 levels of convenience. Seamless is the best, and prohibitive is the worst. Each of these 5 levels is measured in how easy it is for the client to integrate the provider's code. So let's take a look at a few examples. In this first example, I have a scenario. A video game needs to keep track of how long it takes for a player to clear a given level. An updated timer is presented on the screen as the player works through the level, and a scoreboard is maintained in a top score file. Okay, so here's my class definition. I have a date time where get is going to return a string and set will take a string. Now, what's the level of convenience of this class? Well, the public interfaces here are simple getters and setters working with strings. In other words, the client provides a textual string similar to the Sunday, the 7th of December, 1941 at 8 a.m. The needs of the client are quite different. Absolute date or time are not needed, instead elapsed time. Furthermore, the client does not need to set a given time. Instead, the client needs to add a fixed amount of time that has previously elapsed. For the client to use this class, she will need to do many non-trivial things. Taking all these things into account, it would be easier to start over than use this class. This class is thus prohibitive in the context of this particular application. All right, let's try again with the same scenario. This time the client has refactored the class to make it more convenient. So I have the get minutes, get seconds, set minutes, set seconds. So now I'm not working with text, but rather with integers. Now the public interface is asked for and provide the units as integers. If a provided value is outside the range, such as 61 seconds, then an error is thrown and the time is not updated. Now the client needs are unchanged from the previous example to increment the number of seconds it took to pass a level. To accomplish this, the following work needs to be done. Compute the number of seconds that have transpired since the level was started. This is done by getting the hours, minutes, and seconds from the default constructor, and the same from the level started time. The application will have to compute itself the number of seconds that have transpired. So taking all these things into account, the class does provide some benefit. However, the application needs to do most of the work. As a result, the class is convoluted in the context of this particular application. Now we have the same scenario as before, but this time I'm not going to have a date time class, but rather a timer class. I'm going to get both integer and a string in terms of my timer. Now, the first thing to notice is no longer a date time, but a timer class, and this is much better aligned with the needs of this particular application. There is a set and a get method working with seconds, aligning with the needs of the game, and there's also a set and get working with text, and is useful for writing to the scores file. It also facilitates generating a text time for displaying on the screen. Now, it is straightforward for the client to use this application. All the public interfaces are expressed in terms that are easy for the client to consume and produce. There remains quite a bit of work for the client to do to integrate this in the application. The client needs to interface with a system clock. We need to write the display code, and we need to write the file code so the time string can be written with it. Taking all these things into account, the class is very straightforward to use. Data manipulation can readily be performed by the client. It is definitely better than our previous 2 examples. However, there's still much room for improvement. All right, now we have the same scenario before. Now the timer class with more convenient methods. I'm going to get and set, but I'm also going to reset and add seconds. And that is more in the context of what the client needs. So these 4 public interfaces, none of which work with a timestamp. The get and set work with strings, and none of the interfaces use absolute time. They all use elapsed time instead. When performing a time operation in the game, the time of day is less interesting than a time since the level began, and this interfaces work with elapsed time, not absolute time. There are still a few things which the client needs to do. The client needs to know how many seconds have transpired since the seconds were last added to the timer. And this is actually not very difficult to do at all. And the client needs to write the file code so the time string can be written and read from the file. Taking all these things into account, the class is very easy to use. No extra work is required by the client to manipulate the data going into and out of the class. But can we improve it yet more? Let's try this again. Same scenario before, but now the final iteration of our timer class. The 2 public interfaces, start level and stop level, correspond exactly to the events that occur in the game. Better yet, no parameters is required. The class integrates a system clock to be able to perform its own timing. This offloads a great deal of complexity from the client. Another two of the interfaces read and write handle the score file. The client only needs to provide a file handle, and the class does the rest of the work. Again, this removes a lot of complexity from the client's code. The final interface handles the display work for drawing the timer on the screen. If every game entity knew how to draw itself, imagine how much easier it would be for the client to add new elements to the game. Since virtually all the housekeeping surrounding the class has been integrated into the class, and since all the public interfaces are perfectly aligned with the needs of the client, this is seamless convenience, and this is what we strive for with all of our class designs. This is example 2.1.1, .2, .3, .4, and .5 in the convenience chapter of the software design textbook.